Hello? Hello? Hello?
Yes,
Am I
sir.
audible or not?
Yeah, good evening, sir.
Yeah, good. Okay, fine. Okay, so my name is Jasdeep. I would be taking the refrigeration and air conditioning this time. And so today we will be starting from the basics. I want to first of all I want to know like how many of you were there at the when I was teaching the thermodynamics there. If more people would not be there, then some basics will let you know, and then we'll start. Like how many of you are new here first time?
Yes, sir, I am the new. I am also new, sir.
मैं तो मैंने इसको बोल दिया अगर किसी का ट्रांसफर हो गया पुराने बंदे में तो आप तो बकवास भी मत कर मुझे सवाल बता दियो मैं तो सकता ही नहीं सुन के तो आई जाती है
Okay, so I would suggest like
कि वो
please
कहीं
turn off your mic if some question is there,
घर
then you
जाना
can
था
turn
तो
on. Okay.
फोन हो गया फिर घर जा रहा हूँ
So here we will deal with the refrigeration and air conditioning. Okay. So what is the refrigeration? Can anyone define? Anyone right or wrong doesn't matter. Just define. What
Down
is
temperature of a body.
what?
Bringing down temperature of a body or extracting heat or cooling.
Okay, somewhat. Anyone more?
Reducing the temperature of body below atmospheric temperature.
Okay. Somewhat closer. Like we can maintaining a space. Like this is a space. We have to maintain it, and this is the surrounding. So let's suppose surrounding temperature is T naught and it's so if we want to maintain T1 below T naught, so uh, in steady state condition what will happen, it will try to transfer from here to here, but if you want to maintain this place at T1, then means refrigeration you can define as to maintain a temperature below than the surrounding temperature. So whichever means phenomena you are doing, that is refrigeration. Okay, so for that it would not be natural process. For natural process means heat transfers would be taken anyhow, it would be taking place from higher to lower, but we don't want that. So refrigeration will come into picture. So for from basic thermodynamics maybe I would have told if so, whoever don't know, like they should try this. Anyone knows what is the because in refrigeration we would be dealing with the open systems. Anyone what is open system?
Both transfer of heat.
So here both, like air transfer would also be there along with the mass transfer. So some examples like which devices can be used in the refrigeration which are open system? Can anyone explain? Just name.
Condenser, expansion.
Okay.
पावर प्लांट
Expansion valve will start. Expansion valve and
Condenser.
compressor will do.
Turbines.
Huh?
Turbine.
No, in refrigeration why you need turbine?
Sorry.
Yeah, in data like there we can say, but here for as of now we will be not. Okay, compressor and what is the difference between pump and compressor? Quickly, can anyone tell?
Pump handles water. Compressor handles air.
Means for gaseous thing if you want to compress, then we will be using the compressor, and for the liquid if we are going to compress, then it is the pump. Okay, so one is the expansion valve, compressor, then we can say condenser. What is the use of condenser?
Liquefy.
What is the similarity between expansion valve and condenser? Sorry, not expansion valve, evaporator. Can anyone tell what is the similarity between these?
constant pressure.
pressure devices हैं.
Okay, constant. What is the name of constant pressure devices? Can anyone tell?
I
Heat
said
exchanger, right? Heat exchanger, constant pressure device. You would have to remember this because evaporator is also heat exchanger. Work is to just extract heat from the confined space where we want cooling. So it is taking heat from cooled place, evaporator. And condenser, it rejects heat to surrounding, means the temperature is more of working fluid and corresponding to that of surrounding. So both are heat exchanger, just a transfer of heat from one place to another place. So both are heat exchanger and constant pressure devices. Okay. So open system. One thing we come to know, like open system usually we are going to deal with. So what is the work for open system? Work done for open system, can anyone knows?
Minus VDP. Integral of minus VDP.
Minus VD. Okay. So let's suppose the process for PV to the power n. Hello.
Hello, Sri.
Okay. There is a process PV to the power n is equal to constant. So what would the work done for open system?
P1 V1 minus P2
Your voice is breaking. P1 V minus P2 V2.
by gamma minus 1.
Not here, gamma.
Sorry. N by N.
So this is the this. Okay. What are the assumptions here? Can anyone tell? Hello. Hello.
It's a perfect case.
What? Okay.
It's a perfect case.
Yeah. And more important assumption, here we assume like process are reverse in nature. Right? Hello.
Sir, why it is a perfect game?
Actually, thing is ideal. Okay. We can say for ideal gas, but we can say perfect. Okay. Real we can't say. For real gas question would be because real gas PV is equal to NRT applicable. So ideal gas and perfect gas we can think of a similar thing. Okay.
Okay.
So here important thing is reversible process. It is applicable to reversible processes only. Okay. If process is irreversible, then how will you find? Because this would be coming in your question. That's why initially I am telling. Okay. So how you find work if process is irreversible for open systems?
Sir, H2 minus H1.
Why H2 minus H1 only work? This you are saying, right? No. It is for specific means only few specific cases it would be there, or for all cases it would be there.
Only, sir, few specific cases.
So for all cases, how would you calculate that question? Any other way to find the work for specific for the open system work for
Sir,
reversible
H2 minus
process?
H2 minus U2 minus H1 minus U1.
What? Okay. For open system, which equation you generally use? energy conservation equation for open systems. Can you?
Sir, Q plus M H1.
What is the name of that equation?
First
Steady
of
flow energy equation.
Steady flow equation. With this equation, we can find the work for open system, either irreversible, irreversible, whatever it will be. Okay. So what is this that equation?
H1 plus V1 square,
H1 plus.
V1 square, V1 square divided by 2
Okay. Velocity vector.
plus
Hmm.
Z1 sir. Z1.
Okay.
Z1 plus dq divided by dm. Or just q.
First I will define the system. Then system, let's suppose Q heat is we are going to give system and W work we are going to get. Okay. So Q here, because it is the energy inlet to the system and it is the energy outlet. Both would be equal. Okay, work done by the open system. So is it clear where we have to use this formula and where we have to go for the steady flow energy equation? Is it clear or not? If anyone has doubt, then please ask right now. Hello? Should I go forward?
Yes, sir.
Yes sir.
So enthalpy is function of temperature only for all working fluids. Is it fine? Enthalpy function of temperature
Yes sir.
for all working fluid. Correct or not? I guess someone. Okay. So is it correct or not? Just yes or no you reply.
Yes, sir, it's correct.
Sir, for ideal gas.
Huh?
For ideal gas it is correct.
It is correct for only gas. If it is not ideal gas, then it would be function of what? Anyone?
Pressure and temperature.
Temperature and pressure.
Temperature and pressure. That relation knows or not? Okay. Say for internal energy also, it is function of temperature for ideal gas. For others,
Sir, are you talking about Clapeyron equation?
not classic equation. From there, what you will get? You used to get change in pressure by changing in the temperature or change in temperature by change in pressure. That you used to get from there, no?
Yes, sir, yes. H.
From thermodynamic property relation chapter you complete know this thing. So is the function of temperature and anyone?
Pressure.
Volume.
Volume for other gas. You should know now. If anyone don't know like how it is doing, because actually you have to know before learning before learning the RAC you should know thermodynamics. So thermodynamics in phase 1 already completed and all these things I have told there. So you can see lectures also. I think recording are there. Okay, so this thing are done. So quickly I will say like because we have to calculate at each point here. So if someone don't know, for their information I will quickly tell. And let's suppose this is TS curve. And what is this line? Anyone can tell? This line what I am drawing?
Constant pressure.
It is constant pressure line. So you know the enthalpy of this point and this point. and this temperature, pressure constant, sorry, this pressure you know, okay. So this is HF and this is HG. So this is the first point, let's suppose, and this is point A, and this is the second, let's suppose this is the second point, and this is the third point, this is the B point. Okay. So is there anyone like who cannot define the, if you know the property at point A and point B, you know the property of this and its temperature, saturation temperature, you know? Yes. So can you calculate like enthalpy at S1, sorry, entropy at 1, entropy at S2, entropy at S3? Similarly, enthalpy at H1, enthalpy at H2, enthalpy at S3. Would you have calculate or not?
Yes, sir. Yes, sir.
Because I will quickly tell. It is constant pressure line. Okay. So what is the formula for entropy? Change in entropy.
Cp ln T2 by T1.
And T2 by T1. Then is it correct or not? Hello.
Yes, sir.
Is it this one correct or not? Anyone?
Yes, sir. It's correct.
So here it is constant pressure line. So P2 and P constant. So this term would not be applicable here. So simply, if you know the entropy of first calculate the enthalpy, then entropy will calculate. Entropy we can anyhow find. Cp we know for this fluid, and Cp ln, and let's suppose from here to here we would be going. So what will be the T2? What will be the T2? If from 1 to A, if we are
Ts
right, TS.
by T1.
Yeah, TS is same. TA and T both are same. We will TA will write TA by 1. And here you know everything. Cp you will be knowing, TA you will be knowing, T1 you will be knowing. So same way, how will you calculate S2? Anyone quickly?
Sir, S1 to
SF
S1.
SF plus H2 SFG, sir.
Here you use like you have to find the dryness fraction first at that point, and that's why you have to find S2 would be the say plus X SFG, right? And SE would be the SG minus SA. And what would be 3? Same way, like this way from 1 to A we have gone, now we will go from 2 to 3. This would be the Cp and T, C minus D by,
Sir,
yeah.
sir, entirely we can use these equations, sir, because generally these are used for perfect gases, right?
What?
These equations Cp ln T2 by T1. These equations are especially meant for perfect gas molecules. So will we be able to use in state 1?
For my voice is breaking. Is it for others? Or? Hello.
नहीं sir.
1 minute.
Sir, we can hear you.
Yeah, I think my microphone here earbuds are somewhat problem. Okay. So can you speak again?
Yes, sir. Sir, actually, this DS equation is there, sir. Cp ln T2 by T1, this one. So here, these equations are meant for perfect gases only, right?
Yeah, ideal gas and perfect gas. If two words are there, then we can use this equation. If real gas is there, then we can't use that time. Okay.
So, but actually, in state 1, it is in liquid state, no, sir?
State 1 you are saying, right?
Yes, sir.
This one. Here CP would be both for would be different. Here CP would be of liquid, and here CP for the gas. And actually, this equation is valid for only gases, okay? But
Yes.
it will come same. Because why? Because what would be the Q from here to here? What is the entropy? dq by t, right?
Yes.
And what is the dq? cp dt, right? dp dt by t, and then simply we integrate, then same equation will come. This is for the liquids. Got it?
Yes.
For liquids anyhow this equation work. If pressure even varying, then also it can work. So that equation will come from here. So same way we can calculate, right? What would be the HA? HA we know. What would be the H1? It would be the HA minus Cp of liquid and TA minus T1, right? Hello.
Yes, sir.
Yes.
It is clear, sir.
Yeah. Okay. So same way we can find H2. H2 would HA plus X HFG. And what would be the H3? Same way like H1 we have written. It would be the H here apart from minus, here it will become plus because HB would increase from this one. So HB plus Tp of vapor or gas and T3 minus T2. So this formula you should be knowing, but I told you maybe it might, you might not be knowing or forgot, so it would be better. If anyone want to note those formula, note it. Otherwise, take a screenshot. Then,
Oops.
okay, so then we will go forward.
Excuse me, sir.
Yeah.
Sir, one small doubt. Sir, actually, in case of state 1, you told that actually in even when pressure changes, we can use this formula, sir. So same thing we can apply, sir. Minus R.
Yeah. For actually for pressure, you have you used like 10 cycles? Have you done? Like 10 cycle, actually what happens? This way. Here pressure will like how much? Any idea? Here pressure means a lot big, means it would be close to bottom. It is up to 40 to 50 bar or some so like that. And here pressure is like something point some K like that. Yeah, 100 K like that it will be. So from 100 kPu we are going to this much bar. So here pressure is increasing.
Yes, sir.
So it is pump here. Pump what you would have calculated like what the work of you take here we consider it is liquid, so liquid volume won't be changing by pressure much because it will be considered as a incompressible fluid, okay?
Yes.
So here simply we apply VDP, V and change in pressure simply, minus V and dP. What here pressure and whatever here pressure, that we write here and find forward. Right? This way we will find, right?
Yes.
Is it clear or not?
Clear, sir. Yes, sir. Clear,
Yes, sir.
sir.
Okay. So on liquids we don't be consider the effect of pressure when it would be varying because it is compressible, incompressible in nature. anyone what is the COP and difference between COP and EPC? Quickly, can anyone tell? First, what is the difference between COP and efficiency?
So COP is for work absorbing devices, and efficiency is for work producing devices.
Okay, this is for the which devices we use this. And what they told, what value of the COP, what value of efficiency generally signifies? Can anyone tell? What efficiency tells? How good system is, right? Generally this
Yes.
tell, right? If more is the efficiency, more would be the more good system would be, right? So same way for COP. COP for absorbing devices. Two type of work absorbing devices. One is the refrigerator, another one pump. What is the difference between both? In one line, can I hear?
Based on the effect of
Heat pump we use.
Sir, the
When
efficiency is
What?
when we have to heat our body.
No, just some proper thing, proper define
custom
what is the heat pump.
Sir, the desired effect is heating the body.
Actually, for refrigerator, what I told here, first slide, this when we have to maintain a space below surrounding temperature, then device used as refrigerator. That is a phenomenon is refrigeration, right? Same way. Heat pump when we want to maintain a space, let it suppose temperature T1 and surrounding T0. If we want to maintain a space T1 is more than T0, then whichever device we are using it is known as heat pump. Okay, simple one word definition you remember. One space that temperature you want to maintain above the room temperature, and then which device we are using is heat pump. So similarly for refrigerator also. T0, T1, and whenever T1 is less than T0 means we want to change this temperature below the surrounding temperature. When we, that time we will be using the device is refrigerator. Okay, clear or not?
yes, sir.
yes, sir.
And what is COP now?
Not extracted divided by work done. Refrigeration effect by work supplied.
Okay, refrigeration is okay, but it is for the refrigerator because we used to find a COP for both things, so you used to write desired effect. Means for heat pump desired effect is the higher temperature, and for refrigerator desired effect means what you want. Here you want higher temperature in your and here you want lower temperature in your space. So that is the desired effect. Desired effect is pressure or what? Can you tell?
Desired effect is heat pumped out.
It is the amount of heat that you have to extract. It is not you write it is the temperature T1. Side effect upon energy input. So one formula you would be knowing, right? Because let's suppose this is the temperature T2. This is a work absorbing device. This is the temperature T1, and this is Q1, and this is the Q2. Let's suppose this is the W we are giving. So let's suppose one time it will act as a heat, one time it will act as a refrigerator. Then what would the relation between both COP?
COP heat pump equal to 1 plus COP of refrigerator.
This formula you should be knowing. Okay. So my one simple question is, let's suppose it is the Carnot cycle, think of, okay. Let's suppose this is the Carnot engine. Heat engine. This is the T1, this is the T2. Heat Q1. Let's suppose this is the reversible engine. So what would be its efficiency?
Q2 by W. Sorry, W by
T1 minus T2 by T1, sir.
What?
1 minus T2 by T1.
T1 same way. Okay. Now I want to say how you can increase this efficiency by varying the temperature of this reservoir. Can anyone tell? Like by doing this it will increase, by increasing this it will increase. Can anyone tell for heat engine?
By reducing T2 and increasing T1.
Means T2 decreases and T1 increases. Now my question is, if we want to, we will decrease the value of T1 and T2 same. Means like, well, let's suppose 5 degree will decrease this and 5 degree will increase this and 5 degree will increase this. Where the increase in efficiency would be more? My question here or not?
Yes, sir. Lowering the
Yes.
temperature, sir. T2. Decreasing the T2 is the most effective way to the increasing the efficiency of the heat engines.
So decrease in T2 would be more effective than right?
The decreasing T2 and constant T1.
Yeah. Means one by one we have did, and then we have to find which is more better. So we said decreasing T2 is more better. How you find this? Can anyone tell? If anyone to find like much it is decreasing and increasing.
Third law of thermodynamics, sir, to maintaining the 0 Kelvin temperature
That
as
is
the
fine.
ambient temperature.
I am saying like I would say like 5 degree temperature of T2 will decrease and 5 degree temperature of T2 will increase. Then how much percentage of efficiency by here you will get means difference in how calculate. How you have found? Either remembered or anywhere. How will you find? Anyone? Because same way we are going to do for our refrigerator also, okay? That's why I am answering here. Any idea? If you don't know the change with relative to something, what you used to do?
Divide करते हैं सर.
Derivative we used to take. We want to know the change efficiency by changing in temperature T1. We want to know the change in efficiency by changing the temperature T2. Means if we want to know the change in efficiency by varying by changing in the temperature T1, then simply differentiate it with respect to T1. Something you will get, right?
Yes, sir. Yes, sir.
Similarly, change in efficiency by varying temperature T2, something you will get, right?
Yes, sir. Yes, sir.
So here some functions you would be getting, and here also you would get some function dt1 and dt2. I already told it is 5 degree, right? I told na just decrease by 5 degree.
Yes, sir.
So simply here some value you bring and multiply that, and some value you getting for this, and when this for whichever case then it is more effective. So this way you have to find like. I am not going to find here, just I showed the way like this way you can, okay. So similarly my question, which way is more effective way to enhance the COP of this system, COP of our refrigerator? That is my question. My question clear or not?
Clear, sir.
So two cases we will make, one for refrigerator and one for heat pump. So I think COP for both you find, let's suppose it would be the T1 by T2 minus T1, and it would be the T2 by T2 by T2 minus T1. So when the way I have tried showed you, same way when you do this way, then you will get like here increasing the decreasing the TH would be more effective way, and here opposite will happen, right? Hello. And increasing the TL here would be more effective way. So remember these things, because in MCQ directly it might ask, then that time you have to find like how it is working. If you don't know this way na, then simply you are putting temperatures and trying to find out, it will take time. So simply write it and differentiate it and get it. Okay.
Yes, sir.
Is it clear to everyone or not?
Yes, sir.
Yes, sir.
Okay. So now we will simply, what would be the cycle for heat engine?
Sir.
Mankind cycle.
Excuse me, sir.
Carnot cycle, sir.
Carnot cycle, right? So same way for refrigeration, what would be the ideal cycle?
Reverse Carnot.
It will reverse Carnot. Same way, I am not going to explain each of the process here. Just simply I will draw, because in the TS diagram, a Carnot cycle is like a rectangle. So here same rectangle will come, but it will come anti-clockwise, right? Hello.
Yes, sir. Yes, sir. Understand.
So quickly you have to tell which process is which. 1, 2, 3, 4 I have mentioned. 1, 2, 2, 3, 3 to 4, 4 to 1. What is 1 to 2?
Compressor work.
Diabatic compression.
Diabatic compression. What is 2, 3?
Constant pressure process.
Huh?
Constant.
Isobaric condensation.
Isothermal.
Isobaric
Constant
isothermal it is.
Constant temperature process.
Yeah. It is isothermal what?
Heat rejection.
So 3 to 4? Same way.
Adiabatic expansion. Or isentropic.
Same way here, isothermal heat addition. Yeah. Same way here, it will take heat from the wherever we want to cool the space. Okay. So this is the way. So what is the COP of this cycle? COP of Carnot refrigeration cycle or reverse Carnot, RC we can see here. Both way we can write. So what would be the value of this?
T2 minus T4.
1 minute. What are you saying? Yeah. Tell.
1 minus T2 upon T1.
T2 minus T4.
T2 minus T2. Okay.
T2 by T1.
Okay. Because here T1 and T4 are same. Right. And here T2 and T3 are same. So simply we can write as a higher temperature and lower temperature. Would be better. So same way, any way you write, you can write. Okay. So you know now what is refrigeration?
सर यहाँ पे COP के सबस्क्रिप्ट क्या है ये? CR?
COP for cannot refrigeration cycle. Yeah, we are not. If you write, then RC it will become.
ओके सर, पर ये एक्सप्रेशन सही है क्या? सही नहीं लग रहा सर.
Oh, sorry. Refrigeration effect is T1 minus T4, right?
सर
What
T1
is
माइनस
the
T4 तो सेम है. T1 माइनस T4, T1 एंड T4 तो सेम है ना.
So how will you find the refrigeration effect here?
T1 बाय T2 माइनस T1. अरे
This way,
मतलब
right?
COP बता रहा था.
This way.
T1 बाय T2 माइनस T1 होगा ना.
Okay. So why water is water we use as a refrigerant not?
या we
Sir,
could
used in lithium bromide refrigeration system, sir.
Okay. When we can use it? Any application? Like for ice making, can we use water as a refrigerant?
No, sir.
Okay. Water can be used. Water is a good refrigerant, but it has only one bad property. What is that property?
Not making the below the 0 degree centigrade temperatures.
It's a freezing point is less than freezing point is 0. Freezing point is less, I can write. So that is only property that otherwise water is very good refrigerant.
मतलब freezing property is high, freezing point is high, इस वजह से.
Freezing point is high. If we want to make ice, then we have to go below in minus temperature we want, and that time should be liquid. Otherwise, it will freeze in the system.
Okay.
Okay. So one more thing. Can you know COP of like AC and COP of refrigerator? Which is more?
Air conditioner, sir.
Air conditioner, right? Why?
Because of working in the positive temperature, sir.
Same way, let's consider it is also working on the Carnot cycle. Then COP of air conditioner would be more because its desired temperature is more, because AC when generally our AC is working close 21 to 23 degrees Celsius, right? And where refrigerator working close to -5 -10 degrees Celsius, -5 to -10 degrees. So when this we will try to find this COP, then the COP of AC is more. Then what is the COP? COP is more, and but if COP is more, then our bill should be less. That is our main we used to think of. Then why in the AC our monthly bill is more? Anyone?
Because the volume to cool is very much large.
It has to cool the bigger surrounding. AC used to extract more amount of heat, and while for the fridge it is very small amount. So although COP of the AC is more, but it has to extract more amount of heat. So that's why we have that monthly bill is more. So what is the work input? It is the desired effect by COP, right? If desired effect is very much, then what will be the COP? Then energy required is more. So you can calculate this way. Sometimes question will come like you can find the desired effect, but you have to find the how much monthly bill you have to pay. That time you have these things you have to keep in mind. Like you have to find the work input, and work input will to which unit? Kilojoule, right? And okay, this simply one question will solve, then it will be better, I think. And one more thing I want to let you know. Suppose because heat transfer it is not clear, temperature is 1000 Kelvin, and let's suppose another reservoir at 500 Kelvin. here working what this in between it is showing? Anyone can tell me what it is?
Heat engine, sir.
हीट एक्सचेंजर।
This one.
सॉरी सर, सॉरी, मतलब ये दो डिवाइस हैं, हीट इंजन और एक मशीन दोनों है।
हाँ सर सर।
Huh?
हीट एक्सचेंजर और मशीन दोनों है।
Giving working fluid, it is doing
Basically, it is
it is doing
combination of
refrigeration.
devices
Heat
that can
removal.
circulate working fluid in cycle. Okay, it is the its meaning is like that only. Like it will complete the cycle. So my question is like he will not transfer like it is pressure 500 here, 500 here. It will not transfer, right? Hello.
Yes, sir.
So thing will come like in questions it will tell reservoir at this fluid temperature 500 Kelvin, sorry 500 Kelvin and 1000 Kelvin, and it transfer from reservoir to actually in refrigerator what flows? Refrigerant flows, right? Hello.
Ah, yes, sir. Got it, sir. Continue.
So if it will say like he transferred from reservoir to fluid, there we used to maintain some degree Celsius temperature difference. Like let's suppose here we are maintaining 30 degree Celsius temperature difference from both sides of working fluid. So from here surrounding will when heat transfer will go from here to here when its temperature is how much? Less 970, and its temperature would be 530. Then only 30 degrees Celsius difference is there. So my question is for computing the COP, which temperature you will know? Got my question or not?
530 and 920.
Huh?
सर 530 and 970।
530 and 970.
Yeah. So in order to calculate either efficiency, same thing can happen with heat engine also. Okay. Efficiency or COP, you to take temperature of working fluid. Okay, got it? Hello. Here temperature of working fluid is like it is 530 970. Clear or not?
Sir, but it should be less than 530, na?
Which one? No, just I said
Wherever
like, just I said like if temperature, let's suppose here the temperature difference is 30 degrees Celsius, that's why I took 530.
हाँ सर, 470 होना चाहिए वो।
Which one?
ये 530 की जगह पे, क्योंकि वो हीट एक्सट्रैक्ट कर रहा है ना, तो लो टेम्परेचर होना चाहिए ना वहाँ पर।
Oh, sorry, opposite I wrote, I think. Okay. Here okay, 470 and here also it will opposite I think.
1030।
Sorry. No, here it is correct. Here 970 will be there.
So can you kindly repeat this point?
सर 1030 होगा ना,
Why?
बिकॉज हीट इज फ्लोइंग फ्रॉम, मतलब कि हीट इंजन की तरफ से 1000 केल्विन की तरफ जा रही है, तो
That's why giving work ना, that's why we are giving work.
तो सर वहां पर 970 की बजाय 1030 होता ना।
Why?
Otherwise heat will not be able to flow into that 1000 Kelvin device space.
I think it should be this only. 1 minute.
सर 1030
Yeah, sorry.
सही नहीं है।
Because higher to lower. Okay. 500 to 470 to 1000.
हाँ सर, अब सही है।
So actually main is like you have to take the temperature of working fluid. And the temperature of working fluid would be you have to consider way more than the temperature of reservoir. Okay, this thing also you can take. Same way for heat engine also we can one example I can take.
So that means if the reservoir temperature is given and the working fluid temperature is given, you must
Ah,
consider the temperature of working fluid. Proceed.
what at the end what you said?
So means like if both reservoir temperature and the working fluid temperature is given, we must consider the temperature of working
Working
fluid
fluid
only.
only. Yeah, yeah, that's the thing. Okay. Sorry. So here next is that the definition of turn off refrigeration 1 TR. Actually, in some cases it would not like this much heat we are extracting, this much heat we are extracting. They will say like 2.5 TR we are extracting, 4 TR we are extracting from a space. So then you should be knowing like what is 1 TR. Can anyone tell what is the definition of 1 TR?
Quantity of heat released by water at 0 degrees Celsius to convert into ice at 0 degrees Celsius in 24 hours.
Like some mass would you would converting, right?
हाँ
So
sir,
it is the
1 kg, 1 kg.
no. It is amount of heat required. Amount of heat required to convert wa- uh, to convert water into ice
At 0 degrees centigrade.
water into ice at 0 degrees Celsius in 24 hours
24
of
hours.
1 ton.
Ah,
1
1
ton,
ton
but
of.
usually we used to say like 1 ton is 1000 kg.
Here it is 907 kg.
Here it is like it is in pound. 2000 pound, but when we convert that into kg, approximately it will come like I think 1906 kg. Yeah. Okay. So when will, because now when you calculate, then it will become mm, in some kilojoules it will come. But when you divide by 24 hours and seconds, then 1 TR will become a watt. How much? Anyone?
Not 210 kilojoule per minute.
Huh?
3.5 kilowatts.
67.
0.5167 more approximate we can write.
Yes, sir.
So remember this thing, because many times like they will say like 1 TR 2 TR, so simply we have to multiply it. Okay, clear or not? Hello.
Clear, sir.
Yes, sir.
Okay, do this problem, and then one conventional problem I will give, and then class will solve more problems, and we will start VCRS that time. Okay, everyone read the question and have calculator along with you. This time I will not be solving, for today we will not be solving much questions, but in from next class we will be solving questions. Okay, and the question from conventional side will do, because there we can solve one question and a lot of question we can cover. Because today only basics we have studied, so that's why I haven't took much question. So here I will quickly read.
Sir, in one ton of refrigeration,
What?
T means TON, NE or TON. In ton of refrigeration, it's TON, NE or TON. I mean, house.
In one ton of refrigeration, then
The value is 906 kilogram.
yeah. That we took, right?
It's not 1000.
No, I haven't said 5, not 6.
Okay, sir.
सी आ रहा है सर
Okay. Hello?
5, sir.
सी सर
1 is 5,
6.
1 is 6. Any other answer?
C.
Okay. So, we'll read. Is the heat engine with given efficiency of 0.4. Here they have given the efficiency of 0.4 and R is the refrigerator, and then Q2 plus Q3 is 3 times of Q1. The CO of refrigerator we have to find, right? So, efficiency given, so we can find the work done here, right?
At first we have to calculate the Q2, and after that we will get the efficiency
Directly
of
work done also we can find, right? So,
yes, sir.
1 by Q1. So, it is given as how much? 0.4. So, it will be how much? So, 2.5 of low. We can say. Q2 you can find, right? Q1 is 2.5 of low. In terms of W, you have to find in one like sim parameter you have to find things and it will cancel. Okay, any parameter you can use. So Q2 would 1.5 of W, right? Hello.
Yes, sir.
So from here we can find the things. Q1 knows Q1 is this, and Q2 also we knows, and Q4 we can find from. Okay. So what is 4 in terms of W? 3 times Q1 means 7.5 of Q1, 3 times of this, and minus of Q2. Q2 is what? 1.5 of W. Sorry, 1.5 of W. So what is Q4? 6W, right? Is it clear or not?
Sir, how to get the Q2, sir? How to get Q2, sir?
Q1 you knows, right? Q1 is what? 2.5 of W.
Yes, sir.
And out of 2.5 we got W1. So whatever is remaining they'll come out this way, right?
Okay, sir, please.
So simply what would the COP of refrigerator? Refrigeration effect by energy input. Refrigeration effect is what? This we have found 6W. And what is the energy input? It is W. So total answer would be 6.
Sir.
Hello?
Yes, sir.
Yeah.
Sir, if we do that 1 minus Q1 by Q2.
Any way you do, no issue. You can
Then
get
then I am getting the answer is 5, sir.
Okay, what you did?
Okay, sir. Let me tell you. Actually, at first, as the efficiency of the heat engine is 0.4, so 0.4 equal to 1 minus Q2 by Q1. Then getting Q2 equal to
1 minute, we'll write along with you. 1 minus Q2 by Q1. Then
I'm getting the value of 1 double equal to.
Actually, I'm not able to hear you what you're saying.
Hello, sir. Am I audible?
What do you find from here? Just quickly tell.
Actually,
Q2,
I'm getting
Q2
the
or
Q2.
Q1? Okay.
Q2.
Q2 you found. Q2 you found, then how much it would be? 0.6 of Q1, right?
Q1, yes, sir.
Then what you did? Then you simply put here, right? Q2.
Yes, sir.
Okay. Then when you put here, then what will become? This will, Q4 will be how much? 2.4, right? 2.4 of Q1. And now what W in terms of Q1 you tell. If you are solving in terms of Q1, then you have to solve in terms of Q1. What is the W in terms of Q1? 0.4, right? Because efficiency
Yes,
is, so now divide it, 6 will come now.
and COP of refrigeration equal to Q3 by W.
Why Q3? Refrigerator, not heat pump. Getting or not getting? Even if you are calculating Q3 by heat pump, now it will come 7, not 6.
Okay, okay.
Clear or not clear?
Sir,
Q4 is Q4 by W, and Q3 is Q4 plus W. So 1 W will more come. So 7 will come. Clear or not?
Yes, sir, clear.
Okay, we will do this and then homework we will do. Just read this question. 1 minute I will give and then we will solve. It is simple question. Here given that I will write it. And from next class, if someone is not having calculator, please took. Otherwise, no problem will be solved. Refrigerator stored 36 kg means mass they have given 3600 kg of a fish at a temperature 27 degrees Celsius. The fish has to be cooled to minus 20 degrees Celsius for the preserving it for a long period without oxidation. The cooling takes place in 10 hours. The specific heat of fish is this above freezing point of fish and the 0.5 below the freezing point, which is minus 3 degrees Celsius. The latent heat of thing is this. What is the power to drive the plant? If actual COP is half of the ideal. Like how many of the who haven't got like what to do here? Please can raise hand. Hello.
Yes, sir.
Is there anyone? If someone is like that, then I will start from basics. That's why I am asking. If you are able, then I will do quickly.
Able to do, sir. It is calculate this in school. He taught
It's
me.
not like 1 or 2 people. Na. If other will say like 4 people, 2, 3 people, even 1 people will say like I am not getting how to do. Then I do from 0. Means slowly I will do. If everyone is getting what to do, then I will do quickly.
So can you explain?
No,
What?
sir, I don't know, sir. No, sir, I don't know, sir. So please solve it from
Yeah. If
0.
someone is not getting, then you tell like don't go fast and like that you have to tell. Okay. So first here 1 minute. Mass we know. So what is this? A refrigerator storage is supplied with this much kg of fish at temperature 27 degrees Celsius. And the fish has to be cooled to minus 23 for the preserving it for a long time. Means from 21 degrees Celsius to minus 23 it has gone. Like this we will. Let's suppose. Oh sorry, 1 minute.
Sir, can you tell the answer?
You tell, I will check.
60 आ रहा है 60 किलोवाट.
Exact 60 kilowatt. 60 I think wrong. 60 kilowatt, huh?
Yes, sir.
Check. I think it is not correct. Do again. Yeah. Okay. So from we have to this at 26 degrees, right? and then it started cooling, and I will give example from water, then it will be better to. The freezing of water,
0 degrees
Zero
Celsius.
degree.
0 degree, right? So let's suppose we cooling water from 13 degrees Celsius to minus 7 degrees Celsius. Okay, we will cool like that. So from 13 degrees Celsius to 0 degrees Celsius, which type of cooling would be there?
Sensible
Sensible cool. Sensible
cooling.
cool.
And here we will be getting 0 degree Celsius. It is liquid here. Here 0 degree Celsius liquid will be get. And then again here solid will become, but its temperature would be 0 degree Celsius only. So here which type of latent cooling will happen? Got it?
So, our screen is not presented. Sir.
Is it?
नहीं सर प्रेजेंटेड है, हमको तो दिखाई दे रहा है.
I haven't added anything. You just refresh, it will come. I think. Refresh or just leave the meeting again, join. So after 0, when we will cool again sensible heating will come. Sensible cooling will come. And here you have to keep in mind, here the C of liquid you have to use. Okay, just keep in mind. Here Cp of solid you have to use. Only these mistakes you can do, otherwise everything is correct. So same way we will do for here now. So here freezing point is minus 8 degrees Celsius, minus 3 degrees Celsius, and after this it will freeze. Means here it is liquid, and here it will be solid. It will become so, but it is minus 3 degrees Celsius only. And after that, which temperature is there? Okay, so we have to go to 23. Here what is the value P? 2 kilojoule per Kelvin. Right? What is the heat here? 230 kilojoule per kg. And what is the state here for the heating after freezing? 0.5 kilojoule per kg. So now simply we need to find here we have to find like heat required to extract from the you will find. So per kg. 2 into 27 to 3 means how much? 30, right?
सर 12 किलोवाट आ रहा है.
Is it clear or not? Hello.
Yes, sir. Proceed, sir.
So here sensible heating will be mCp delta m1 is 2 and delta T is 12 to minus 3, so 30. So here latent heating 230 per kg. So 230 is simply we are 1 kg, and here again 0.5, and here 20 degree decrease, minus 3 to minus 23. So 0.5 into 20. So how much it will become? Say 70 and 300 kilo per kg, right? So for 3600 how much it would be? Total Q total would be 300 into 3600 because here we power. Power means in unit can we want to know how much we have to give. So it is the total, it is in kilojoule and it is happening in how much time? 10 hours. So in hour it is happening. 10 hour means per second. If we convert 10 hour, we convert to second, it becomes 10 into 3600, 3600 will go.
30 kilowatt.
Here it will become about 30 kilowatt. We have
सर
to, yeah.
सर इसका आंसर 12 किलोवाट है क्या, वो जो पावर रिक्वायर्ड है?
I don't know actually. I will see and it will come soon. So anyone can tell like how you will now know the COP now? Tell. What is the ideal COP?
TL by T minus TL.
What?
TL by TH minus TL.
Simple cannot, reverse cannot we have to use, okay? And what is the TL? TL is
250.
and what is the TH? TH is this. You have to convert everything into Kelvin, not put in degree Celsius. So what is the TL? 250.
250, right?
And what is this?
280 minus
I think 50, right? TH minus TL is 50, right? 27 minus of minus 23. Yeah, minus 23, like that we can do. H is this 27 and the Kelvin also do because scale is you have to take difference, so anyway you can take. So it will become COP is 5. Which COP it is? Actual COP. Yeah. Ideal COP is 5 but actual is half of that. So actual COP would be what? 5 by 2 means 2.5. So we know COP, we know what amount of heat we want to extract. So energy input we can easily calculate. It would be, what would be the formula? Can anyone tell? Hello?
Q by CO.
Desired effect by actual CO.
So here would be like whatever amount we have to extract.
30 kilowatts.
30 divided by 2.5.
2.5.
So total will become 12 kilowatt. Okay. So it is the problem like here you have to find like how much total amount of heat you are extracting. Then you don't know what is the COP. You calculated COP ideally by first. Then you calculate the actual COP on the basis of given condition. You calculate the amount of power required. So same way you can say like for 1 unit you are going to pay 5 rupees. In whole month you are going to how much bill? This type of question also can be done. Okay.
Yes, sir.
Yeah. So I think okay, 2 simple problems are there. Just to take the screenshot of that and next class will solve. Just to let me know the answer. The way we, I think it is the similar we did. I will give the hint and you try. In the check refrigerator 2 degrees Celsius it is given, means it's the desired effect temperature they have given, and else on the average thermal load this is the defect that also he gives. The ambient temperature 3 degrees Celsius, ambient temperature also given. The CO of refrigerator is equal to 0.15 times of the Carnot refrigerator. So ideal COP you can calculate. Ideal COP that you get, and the actual would be the 0.25 times COP. So you would be knowing the actual COP, and after that you want the electricity consumption. So we know the thermal load. Thermal load is what? Kilojoule hour they have given, but here they want. So you convert that to kilowatt first. It is the like this is the desired effect DE, right? Desired effect 8000 by 3600. It will become in it will come kilowatt Only you can find W. W would be desired effect by actual COP.
1.51 kilowatt.
COP actual. This way you can take it might be 1.51. Okay, this is an answer. Right. Okay, just try. If answer is not coming, let me know in the next class. I will just quickly give hint for this and next problem. You take a screenshot of that, then we'll go. Should I go?
Yes.
Hello.
Yes, sir.
Yes, sir. Take a screenshot.
So here also same program. Refrigeration system of an plant working between these two temperature ranges, they have been lower and higher, produces 20 kg of ice per minute. Per minute it is asking. From water at 20 degrees Celsius. Specific heat of what is this, and the latent heat of water is the refrigeration capacity of the refrigeration. What is the refrigeration capacity? Only desired effect we have to take, right? Simple problem is it. In kilojoule per minute. In 1 minute, how much ice there is? You have to take. Getting or not
Getting, sir.
Simply you have to find the desired effect. No COP, nothing. So try to solve this problem. Let me know the answer in next class. It's a simple problem. Yeah, that's why I am not done.
सर इसमें आइस जो प्रोड्यूस हो रही है -5 डिग्री सेल्सियस पे हो रही है, मतलब उस तक का.
No. Because here water they start from 20 degrees Celsius. So it is, I think they have given here. So this system working as produces 20 kg of ice. It is ambiguous. It is a problem from the ESC. Okay, there you sometime ambiguous problem they used to give. Here they haven't mentioned. So first you have to calculate for 0 degree Celsius ice. If your answer is not matching, then you have to go for -5 degrees Celsius ice. Someone would be matching out of these two. But it is ambiguous. They haven't mentioned. Most probably no nothing given, but it would be going till -5. Hello?
सी आ रहा है आंसर सर.
-5, right?
नहीं सर, 0 डिग्री सेल्सियस को लेकर सी आ रहा है.
Okay, then it would be the answer. Otherwise, it won't be mentioned.
सर स्पेसिफिक हीट ऑफ आइस इज 2.
No? Ice. Don't remember it. Mostly sometimes 1.9, 2.1, anything kind of. Okay, so for today it would be the thing. Next class we will start VCRS, and that is the important part actually. Here just it is for the basics. So he just came to know like how enthalpy, some radiation is there, pressure varying. So how we will be processes we are going to calculate the enthalpy. First we will see the VCRS, then quickly go through the separate on site. That way, yeah.
So for the state one in the dome, I mean, we have calculated the value for the entropy S1.
But actually, I am not able to hear properly.
So while we were discussing that TS diagram, I mean that graph of the ranking.
Yeah.
The state entropy at state one is given as Cp of liquid ln Ta by T1.
Yeah.